So number one, it says, write each polynomial in factored form. We could check it by multiplication. That's why last time we were re-going over how do we multiply polynomials. So we can check it by multiplication, and then I added in find the zeros as well. So here we go. Looking at this problem, we're going to solve it. We're solving it by factoring. The first thing you check is there a greatest common factor? So what should I factor out? You're right. So everybody write it. Pull out a 2x. Now let's go back, divide each term by 2x, and see what's left over in each term. Okay, right here, what's left over? You're awesome. And right here, plus 5x. Very good. Let's say that correctly, plus 5x. And then right here, plus 6. Loving it. So what you would check is you'd say, okay, great. I have one linear factor. Now you should be checking, does this quadratic continue to factor? Because remember, if it does factor, we want it factored completely. Let's check. What multiplies to be 8 times c, what multiplies to be 6, and adds up to be 5. 2 times 3, but I want to point out something. 1 times 6 sometimes gets people. Because they'll say, oh, negative 1 plus 6 does equal 5. That is true. But does negative 1 times positive 6 equal positive 6? No, so we would say, we know that these are not the factors, but these two are, right? Now, once again, can I quick factor the quadratic? Answer so confidently. Yes, our leading term is all 1, so yes. You say this quadratic quick factors to be x plus 2 and x plus 3. And then we won't forget about this bad boy. We have a 2x still, don't we? Now look, we factored it completely, didn't we? Cool. So we've answered the question where it asked us to factor it. Well, now let's go ahead and solve it. Here we go. So the whole goal is to factor it down to linear factors so that we can then set each of those equal to 0 and solve. So here we go. 2x equals 0, x plus 2 equals 0, x plus 3 equals 0. Let's solve for x. Ready? What should I do here? Divide by 2, divide by 2. X equals, what's 0 divided by 2? 0. There's one of our solutions. What do we do here? Minus 2, x equals negative 2. And then subtract 3, x equals negative 3. Now I need you to check something for me. If it's a degree 3, we should have 3 solutions. Was it degree 3? So we have 3 solutions, so we found them all. So what do you think degree 4? How many solutions should we see with degree 4? 4, you're catching on. Very good. All right, go to problem number 3. It says write the polynomial in factored form and then solve. Now it does say check by multiplication, we just don't have a lot of time, but I want to point out something. Weren't last time we asking you to take a polynomial right here and multiply it out. So then if we multiply this out, put it back together, won't we be back here in standard form? So that's just kind of how to check to make sure you factored right, but we don't have time today. Okay, so here we go. What should I pull out here, everybody? I'm loving that you said negative because there's a negative in front. You're awesome to remember that. So pull out negative 3x, divide by negative 3x, divide by negative 3x, divide by negative 3x. Let's write what we have left over. Very confidently. What do we have here? You're awesome. What about here? You're awesome. And plus 9. And then you'd say to yourself, cool, I have factored out the greatest common factor, giving me one linear factor. Let's see if the quadratic continues to factor. What multiplies to be 9, a times c, and adds up to be b, which is negative 6. Negative 3 times negative 3. So you'd say, okay, this piece factors to be x minus 3 times x minus 3. And oh yeah, we also have negative 3x. Once again, this is not solving, this is factoring. If we put this back together by multiplying this out correctly, we'd end back up at the top. But we're not going to do that. Now the whole point of factoring is so we can now solve easily. So let's set each of our linear factors equal to 0 and solve. Here we go. What should I do first? Divide by negative 3, you're right. X equals 0, you're awesome. And over here, x equals 3 and x equals 3. Okay, awesome. Check again. What is my highest degree? 3, and I have 3 solutions. Very good. Now, fun fact for you, in secondary math 3, we start writing this a little differently. We write it like this, x equals 0, and then we write x equals 3. Now, it happens twice, so we do have to write something here, but we don't usually write it out twice. Here's what we write in sec 3 from now on. If it happened twice, that's called having a multiplicity of 2. So we would say x equals 3 with a multiplicity of 2, which you're like, well, that was a lot harder than actually just writing this. But that's just how you're going to see it written. So I would practice that. So if it happened more than once, that's having a multiple multiplicity. So I have x equals 3, and it happened twice, so that's a multiplicity of 2. So let's pretend just for kicks and giggles, we would have got another x equals 3. What we would have said is x equals 3 with a multiplicity of 3. Yep, that's it. So what if I would have had another x equals 3? We'd say x equals 3 with a multiplicity of 4. That's just how they write it. Okay, cool. See, look up here. Factoring, yes. I wouldn't mind if you went like this, like with, like, you know, just like a with, multiplicity, or you could even just go like this, multiplicity, so multiplicity of 2. Multiplicity of 2, that's fine. That does make it easier, I'm actually glad you asked. Okay, so look up here. You're not always going to be able to factor out a greatest common factor. We're going to learn in this unit how to factor all types of polynomials depending on what you're given. So it's not always greatest common factor. However, we check that first. Do you see how we cannot pull anything out in common in all of the terms? So you would factor by, well, if there's ever 4 terms, we factor by grouping. So this isn't on your worksheet. You'd group the first 2 terms, group the second 2 terms, factor out the greatest common factor. So what's in common here? Okay, good. X squared, divide by x squared, divide by x squared. So left is x plus 4, right? Pull out what here? Negative 4, you're awesome. Divide by negative 4, you're awesome. And then x 4. Now everybody understand, not all polynomials factor by grouping. Just because it has 4 terms does not mean it's going to factor by grouping. How do we know it did? Because the Saint-Haven's the same. So it did factor by grouping. So don't I pull out an x plus 4? Now don't write, there's not 2x plus 4s. We pulled out x plus 4, so it divided out, leaving me with x squared minus 4. Is everybody with me? Okay, awesome. So now what we're going to do is we're going to say, okay, that's awesome. Now I factored it, but let's see if it factors more. Well, does that factor more? Let's check. Well, let's factor it if possible, just because we really need practice with factoring. Well, multiplies to be negative 4 and adds up to be 0. Negative 2 and 2. Are we all good? So you'd say this piece factors to be x minus 2 and x plus 2. And now we still have x plus 4, and now we can solve by setting each of those equal to 0 and solve. So I'm just going to skip that step. X equals what? Picture it in your head. Negative 4, x equals 2, and x equals, check, but was it degree 3? Yes. So we should have 3 solutions. Okay, cool. Let's do one more. Like that. 1, 2, 3, 4 terms. That means factor by grouping. Watch though, because this one is interesting. That's why I'm showing you it. Pull out x squared. So then wouldn't x plus 8 be left? Pull out positive 8. So then left is x plus 8. So it did factor by grouping. I pull out x plus 8. And then left is x squared plus 8. Okay, just watching. Now you would say, does it factor more? Well, multiplies to be 8 and adds up to be 0. 1 times 8, 2 times 4. So nothing. So it doesn't factor, so we wouldn't continue to factor, but now we will solve using the most appropriate method. So you'd set x plus 8 equal to 0, x squared plus 8 equal to 0, and solve for x. So wouldn't I subtract 8? X equals negative 8, right? All right, what should we do here? Quadratic formula? Heck no, that's the hardest way. That's why we've learned the most appropriate methods to help with this. Minus 8 from both sides, x squared equals negative 8. Next step. Square root, root cancels out with power, x is equal to. Shouldn't we break that down by hand? Yep, you're way ahead of us. So when we pull out 2 and an I, so we'd have plus and minus to I root 2. Let's count how many solutions we had. 1, 2, 3. That's degree 3, so we're good. Okay, ready? I go. Do problems 1 through 4. You're going to factor them, find the zeros. And then here's a problem number 5 I want you to add on just to the side somewhere. So once again, we just learned how to solve a polynomial by factoring it down to its linear factors if possible. And there's factoring by grouping so far, and there's factoring out a greatest common factor. And then of course, factoring a quadratic if possible. Okay, on number 2, just tell me what you factored it to be. X squared, and then what did you factor the inside to be? X Minus 3 and x plus 2? Okay, now what you really should think of this as, everybody, is this instead. Isn't x squared x times x? So we have x times x minus 3 times x plus 2. So we get 0, 0, 3, and negative 2, don't we?
Yeah.
So we would just say x equals 0 with a multiplicity of 2, 3, and negative 2. And once again, we would check, is it degree 4? So we should have 4 solutions than we do. Okay, all good? Any questions on that? Okay, cool. Okay, sweet. Have you done number 5? Okay, do that one, and then we'll move on. Okay, everybody, we're kind of jumping around a little bit to make it smoother than first hour. You trust me, I learned a lot. So everybody, it says, now we're going to go to 13. It says, now instead of given, so what we just did a second ago is we were given a polynomial, we then factored it out, and then we solved, didn't we? Now instead, what they're doing is they're going backwards. What they're giving you is the solution. They're saying, what's the polynomial that we started with? So this is saying, given these solutions, what's the original polynomial? Given these 3 solutions, what's the polynomial? So first of all, let's test your knowledge and understanding. We have 3 solutions. What degree must this be? 3. You're awesome. So we're working backwards. So you'd say x equals negative 1. We also have an x equals 3. And we also have an x equals 4. Now remember, if we're working backwards here, before we had solutions, we had linear factors that were equal to 0. So let's make this equal to 0. So let's add 1 to both sides of the equation. X plus 1 equals 0 must have been the linear factor if x equals negative 1 was a solution. Am I right?
Yeah.
So subtract 3, we need it to be equal to 0. X minus 3 must have been the linear factor if 3 was a solution. Minus 4, minus 4. X minus 4 must have been a linear factor if 4 was a solution. So we've just done step 1 on working backwards. Now remember, before they were split apart and equal to 0, they used to be being multiplied together and equal to 0. Right? And now, that's why we spent the whole day last time learning how to multiply out polynomials, so we could do this correctly. Now remember, Ms. Christensen gives you a suggestion when multiplying 3 polynomials. What should we do first? Awesome, you're awesome. Multiply 2 of them. Very good. And then combine like terms. Here we go. X times x is x squared. X times negative 3. You're awesome. 1 times x. You're right. And then 1 times negative 3. Very good. Combine like terms. X squared and then minus 2x, isn't it? Minus 3. You're going to want to be really careful because if you make one error here, the whole thing's wrong. And it's too hard to figure out. You just have to kind of start over. And now we'll multiply in x minus 4. So let's do this very, very carefully. X squared times x is x cubed. X squared times negative 4. You're right, negative 4x squared. And now I'm going to cross out x squared. I've taken care of that. Negative 2x times x is negative 2. Yep. And then negative 2x times negative 4. Positive 8x. And I'm going to cross out negative 2. And then negative 3 times x. Okay, good. Minus 3x. And then negative 3 times negative 4. Okay, let's combine like terms and we're done. So we were just working backwards on this one. We have an x cubed, no other x cubes, minus 6x squared, and then plus 5x's, and then plus 12. And now the polynomial in standard form is given that had those solutions. Sweet. Let's do one that has a little bit more to it. All right, number 16. It says, given the solutions or given the zeros, what's the original polynomial? Now this has 4 solutions, so what degree is it going to be? 4. So we have x equals 4, x equals 2, x equals negative 3, and then guys, x equals 0. Let's work backwards. Subtract 4, right? X minus 4 equals 0. Subtract 2, x minus 2 equals 0. Add 3, x plus 3 equals 0. And then look, we're not going to go minus 0. Let's just keep it x equals 0, everybody, right? Same thing as x minus 0. Let's just do x equals 0 then. Okay. Now, before they were split apart, they used to be multiplied together. So we have x minus 4 times x minus 2 times x plus 3 times x. Now look, just times x. We're not going to do x minus 0 because that's doing extra work. Just times x. So everybody understand?
Yep.
Okay. Now from here, anytime you're multiplying 4 polynomials, multiply 2 together, multiply 2 together, then multiply all of it together. So I'm going to multiply these 2 together, and then I'm going to multiply these 2 together, and then multiply those together. So here we go, focusing on the left. X squared minus 2x minus 4x plus 8. You got to be so careful because one error here can just ruin the whole thing. So x squared minus 6x plus 8, right? Sweet. Let's multiply this one in. Isn't it just x times x is x squared?
Yeah.
Time plus 3x, right? So now we're multiplying x squared plus 3x in. There we go. X squared times x squared is x to the 4th. X squared times plus 3x is plus 3x cubed, isn't it? Cross that out. Negative 6x times x squared is negative 6x cubed. And then negative 6x times positive 3x is negative 8. Thank you. Cross that out. Positive 8 times x squared is plus 8x squared. You're right. And then positive 8 times positive 3x is plus 24x's. And then we're going to combine like terms and we're there. Add straight down here. X to the 4th. 3x cubed minus 6x cubed is negative 3x cubed. And then minus 10x squared. Very good. And then plus 24x's. So we just were working backwards. Okay. Practice a couple in that section, 13 through 18, ready, set, go. Skip to that section though, and do come. I should have said that in the video. So it was already factored, so we rewrote it like this, and then we get this solution, and then this one's multiplicity of 2. Okay, there we go. Look at problem number 23. It says find the zeros. Unfortunately, this one's not factored for us. We've got to factor it. But it's quick. We're getting quicker. So we factor out 9x, left is x squared minus 9. Now factor that more. Well, multiplies to be negative 9 and adds up to be 0. Negative 3 and 3. So you'd say this factors to be 9x times x minus 3 times x plus 3. Now we can solve. X equals right here. What would you say without doing it? 0. You see why?
Yeah.
9x equals 0. Solve for x. Divide by 9. 0 divided by... Okay. And then x equals 3 and x equals... There. Now once again, this is degree 3. So we should have 3 solutions. This was also degree 3. Look. Because an x, technically x, if we were multiplying out the front term, it would be x cubed. So we know we should have had 3 solutions here, which we did. Okay, cool. So you should be able to finish up that section pretty quick. Sure. So on number 25, it says find the relative max and min. So we already know how to do this. It's just a review. So you'd go to y equals, type it in, hit graph, and then you would do second trace max or min, whatever you want to find first. I'm going to find the min first. So left bound, I'm going to scroll left of the min, hit enter, right bound, anywhere right of the min will work. Once again, we learned this last time. So our min is at 3.7, negative 8.2. And then find the max. Second trace max. Left bound, scroll left of the max. Right bound. 0.8, 4.1. So max is at 0.8. 4.1. Okay, let's do increasing and decreasing intervals. That will be on the test. So now, once again, I'm going to have my rough picture here. What this was at 0.8. I didn't draw that very good. So our max was at 0.8, 4.1, because it's easier with the picture to know increasing and decreasing intervals. And then our min was at 3.7, comma, negative 8.2. Okay, so we're increasing. Once again, it's x values where you're increasing here and here. So our increasing intervals would be from negative infinity. So from, I'm going to write it above it, negative infinity up to this x value, which is 0.8. Union, and then we're increasing from 3.7 to infinity. Are we going to ace this test? Yeah. That's easy. And then we're decreasing from this x value to this x value. So you'd say 0.8 to 3.7. Awesome. Hey, now everybody go to problem. Okay, no, I actually just want you to look up here. Sorry, I had to go back. I decided to reorder this next few things. Okay. So now we're going to talk about, we know when we see multiplicities, that means it happens more than once, right? A solution that happens more than once. So look right here. X minus 8 squared. If I said find the solutions, wouldn't you just say x equals 8 with a multiplicity of 2? Now what happens is if you have an even multiplicity, so if it happens an even number of times, it's going to bounce at that solution. So it comes down, touches down at 8, and bounces back up. So this is what a quadratic would look like, a perfect U. So look right here though, this is degree 4. So won't I get x equals 8 with a multiplicity of 4? That's still an even multiplicity. So it's still going to cut down, touch at 8, and bounce back up. It's just not going to be a perfect U. Remember how we talked about 4s can have one turning point, but they won't be perfect U's, right? So do you see how that still bounces at 8? Well, odd multiplicities, so it still could happen more than once, but odd multiplicities still cross through. So don't I get the solution -2 with a multiplicity of 3? It's still, because that's an odd multiplicity, at -2, it's still just going to cross through, not bounce. Does that make sense, everybody? So right here, I get a multiplicity -3 with a multiplicity of 5. So it's still, once again, going to cross at -3, but it's still going to just cross through, even though it happens more than once. Okay, so look right here. Let's actually do this one, number 9. It says find the zeros, then graph. Okay, let's do this. So when graphing, this is the steps you take. You plot your zeros. You've got to find the zeros. And then we'll draw in our end behavior, and then we'll draw in max and min. So those are the 3 steps. First, you'll draw in your zeros. So look, this one's already factored for us. So finding our zeros is easy. We get a 0, a 2, and a -5. Does everyone agree? This is number 9 on the front. All right, sorry, I didn't clarify that. So you're going to graph it. Do you know how you picked up some graphs when you walked in? Okay, here we go. So you're going to go ahead. That's the first thing you'll draw in your zeros. Draw in 0, draw in 2, draw in -5. Now, what you're going to do is next, draw in your end behavior. Now remember, with end behavior, you need your leading coefficient, don't you? I don't want to multiply out this whole thing. Remember, with end behavior, all we need is the leading term. So I'm going to multiply out my leading term. X times x times x is x to the third. Isn't it positive x to the third in this example? So won't it be down and up? So that's what you'll draw in next. So second, draw in your end behavior. Here we go. So now, this is the only places it can cross the x-axis. So from this furthest left 0, that's where it's coming down. Since we said it was down and up. And then from this furthest 0, it's the only place it can cross, so this must be where it's going up. We're just drawing in a rough sketch here. Now from here, notice none of these multiplicities are even. It just happens one time. So they cross through, they don't bounce. They're going to cross through. They're going to come and cross through. Does everybody see? But we need to know the max, because it's coming up and then it's going to have to circle back down. Let's figure out how high up. So our third step is to graph your max and your min. So let's find the max and the min. So everybody, now the nice thing is your calculator, you do not have to type this in standard form. You can literally type that exact thing into your calculator. So go to y equals, type in x, parentheses. You have to use parentheses, x minus 2, close your parentheses, and then x plus 5, right? Cool. Hit graph. Now look at my window. I can't see the max, so I'm going to go up higher on the y max. So go to window, y max. I'm going to make maybe 30, 40 maybe. 40? Yikes. I don't need that many x values, dude. Oh, I did x. I was like, what the? Y max. Okay, graph. Okay, perfect. I can see it great. Everybody good? Second trace. Let's find the max first. Somebody else find the min so that we're not spending so much time, because we all know how to do this. This is not new to us. So somebody else go find the min. Okay, cool. Thank you, sir. Okay, our max is at -3 up 30 points. Our max is at -3 comma 30.0 or 30 point something, right? 30.0. So does 30? Now look, I can't draw that in. So obviously it's coming up here somewhere. Now I'm going to look at your work to make sure you knew what point it went up to. So obviously it came clear up here, touched at -3 up 30. So then that's good enough if I see your work. You see how that's good enough for me? Even though it's going off my graph. Okay, and then min. What's the min's point? You said you found the min over here. What is it? 1.1 comma. Is it -6.04? Perfect. So now we can graph our min. It was over 1 and a little bit, and then down 6 point something. Cool. So now we know how far down to go. We touch our min and come back up. That is a hideous graph because it can't fit, but you know, it is what it is. I don't expect them to be gorgeous. Not too hard though or anything, right? Okay. Let's do another one. Just watch this one and then we'll let you go. You see how I have it at 1, -2, and -3, everybody? I just want to show you what this would look like. So, and then isn't this a multiplicity of 2? So watch what would happen. It would cross at 1, it would cross at -2, and then at -3 it's going to bounce. Now look at how I figure out my end behavior. Careful, because a lot of people mess this one up. Isn't this technically x plus 3 again right here? Okay, so when we multiply out our leading term, x times x times x times x is x to the 4th, positive. So won't my end behavior be up and up? Now from here, you would go through and say, okay, there's going to be, let's see what happens. Well, it doesn't bounce at, does it bounce at -3? Multiplicity of 2. So it touches there and bounces back up. Everybody good? Now from here, then it's going to circle back down and touch here. So you would find the max, that'd be a max value, wouldn't it? Max, if it's going to circle and come back down. Do you get what I'm saying, everybody? So you would find the max by your calculator. So you would just type it in, hit second trace max, so then you know how far up to go. Then it's going to come down. I'm not going to do that right now. Then it's going to come down and cross through -2. And then when we need to find our min. So then you find your min so you could graph it as exact as possible. What? I have no idea what happened just now. No idea. I've never seen it do that. Okay, awesome. Well, let's just keep going. Do 1 through 12 on that. Do 1 through 12. Ready, set, go. So these are your steps. Find the zeros, graph the zeros, draw in the end behavior, then fill in your max and min. I mean, do 7 through 12. Graphing test. So on this one, if you read the instructions, it says, graph this using your graphing calculator. So everybody look at the polynomials. Do you see how it's not factored? So we would have to find the zeros by hand, but watch, it's actually not possible with what we've learned so far. If we try grouping, look what happens. We would pull out x squared from this, wouldn't we? And then left would be 2x plus 5. We pull out -4, left is x plus 3. St. Haven's not the same. It does not factor by grouping. We actually will learn later how to continue factoring that and solving that by a different method, but that's not going to be tested on the first test of this unit. So now it would be okay to say, okay, let's just find the zeros using our graphing calculator. So go ahead and pull up your graphing calculator, go to y equals, and type in your function. So you'll type in, this is number 1, you can see it on your page, 2x to the 3rd plus 5x squared, and so on. You can read it yourself. And then hit graph. Now let's make sure our window, okay, my window's not too bad actually, but I really don't need to see that high up on y, so I am going to maybe make y max a little smaller just to get in there a little closer, maybe like 10. Beautiful. Now look what's happening. We are coming up. Isn't the 0 where it touches the x-axis? Isn't it touching and bouncing back down? So don't we know there's going to be a multiplicity of 2 right there? Right? Isn't that what happens when it bounces? Even multiplicity. So it's going to be a multiplicity of 2. Okay, let's find the zeros. Do second trace. And just like max and min, you can actually find the zeros on your calculator. So you'll go down to 0. Now it asks you for a left bound. You've got to scroll left of the 0. So look where my little circle is. Okay, now I'm to the left of the 0. Hit enter. Right bound, right of the 0. Hit enter. You do want it to guess for us. And And that's happening at -2, 0. So our zeros are at -2, 0. Isn't that the same thing as saying x equals -2? But we know it has a multiplicity of 2 because it bounces. So we're at -2, it's going to be bouncing. We'll come back to that later. Now you'll go pull up your calculator again, find the other 0. You'll do second trace, 0. You got to do it again. For each 0, you've got to start over. Left bound, so I'm going to scroll left of it. Do you see how I'm further to the left of the 0? I'm over here. The 0 is a little bit over here. So I hit enter, right bound, scroll right. Now look, oh, my little dot disappeared. Well, that's okay because it's actually still there. It's just not in my window, but it's at 2.7. Isn't that further right than my 0? Do you see my 0 is like at 1.5-ish? So isn't 2.7 going to be further to the right? So I hit enter again, and then hit enter again. It's at 1.5, 0. So we'll just be okay with decimals today with graphing. 1.5, 0. So or x equals 1.5, and that's not an even multiplicity because it crosses through. So now the same steps apply. Graph your zeros, graph your end behavior. Well, this end behavior is nice and easy because it's already multiplied out. And we have our picture on our calculator. But look, practice because this is going to be on the test. Odd, so it's opposite. Positive, so isn't it down and up? So let's draw that in. Down and up. So now our minimum value, let's go down since we found end behavior. Let's just do that right now. How about anyone mad about that? So down where it says end behavior, we would say down and up, and then let's do it let's do it formally. So as x is approaching infinity, f of x is approaching infinity, isn't it? Okay. Very good. And then as x approaches negative infinity, see, it's all such good review. Like when we get to this test, you'll have practiced this so many times. As x approaches negative infinity, f of x is going to negative infinity. Awesome. Now we can continue. Let's find the min value. So you pull it up. Everybody ready? You go. You're probably quicker than me. Second trace, find the min for me. Yes. It's done that before. Okay, find the min for me, everyone. Okay. Oops. You said the min was at 0.3, comma. Thank you, negative 12.2. Were you all able to get it? Okay. So 0.3, which is over barely any, and then down, once again, it's off my graph. Okay. Now isn't this bouncing? So is it going to touch and then bounce back down? So then we're coming down, touching this value and going back up. Okay, find the max. Do we even need to? This 0, doesn't it happen to be our max as well? So our max, if you did second trace and found the max, it's the same thing as the 0 in this problem. So our max is -2, 0. Our y-intercept, guys, this is true for all functions. Y-intercept is when x equals 0. So let me show you how to do that using algebra. Plug in 0. So that would be f of 0. Isn't that when you plug in a 0 for x? 2 times 0 cubed plus 5 times 0 squared minus 4 times 0 minus 12. Isn't anything times 0 just 0? So all those are 0 and we get -12. So we would say 0, -12. Let me show you another way to do that. Y-intercept is always when x equals 0. Look, if you go to, look right here, it says table of values. Second table of values, look. At 0, we're at -12. Another way of doing it. But I always use algebra because I'm an algebra person. Yep. And then our domain. Where's this function growing from left to right? Yep, you're awesome. Negative infinity to positive infinity. For this problem, isn't our range growing from negative infinity as well to positive infinity? Perfect. Any questions on that? So not hard necessarily, just a lot to answer. Okay. What if I had degree 4 that looked like this? Because I had students last hour getting the range wrong. What if it looked like this? Wouldn't my range be, my domain would be negative infinity to positive infinity, but wouldn't my range be negative infinity up to 6? Yeah. Okay, cool. Just making sure. Okay, do 1 through 8 on the second page. That's the end of the lesson. Here's what we're going to do. Don't cross out anything at all, at all. So what's going to be due this time? We don't have time to learn about, do the story problems, but we have to be able to do them. In fact, they're really easy, but we're going to learn those next time if you don't mind, because I don't want to try to cram it in. Does everybody agree? Yeah. I hate not finishing the lesson and having to finish, but also I hate cramming it in. Is anyone mad if we finish this up next time? Okay, so this is what's due next time. On page 1, 1 through 28. On page 1. And then on page 2, 1 through 8. This is what's due next time. Don't cross anything out, though, but you can make yourself a little note, because we do need to finish up the story problems, because you will be tested on those.